The first part of exercise 10 involves a sliding ladder. Man, are these questions popular. A 10-foot ladder rests against a vertical wall. At the bottom of the ladder slides away from the wall at a rate of 1 foot per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So it's a common misconception to think that, just because the was it sliding away from, so just because it's sliding away at a particular rate, that it would slide down at the exact same rate. Or it's even more common that if, let's say, it slid out 1 foot, that it would slide down 1 foot. That is not the case. Why is that? It's because of the Pythagorean theorem. Here's a follow-up little picture to go with that. So we can see that we have a dx dt because it is this x distance that's changing, and it's moving to the right, so it's a positive one. Or I should say that it's increasing. That distance is increasing. I'm going to make it positive. And then I would expect the dy dt, since it's going downwards here, that distance is decreasing. That should be a negative when we're done. All right, so it says part A, which means that apparently there is a part B that's going to go along with this. It's exciting. Okay, so let's start listing quantities as we do. We already have a picture, very, very handy picture here. We've got a 10-foot ladder. So our ladder here, our hypotenuse, I'll call that C, shall I? Our C is equal to 10 feet. Is it constant? Yeah, the ladder is not shrinking, it's not growing. This is a constant number. When is it going to go in? When's it going to go into our equation? At the very beginning, because again, kind of like these 6 miles in the airplane question from before, it's not changing. So this goes in and before. Differentiating. What else do we have? It slides away from the wall at a rate of 1 foot per second. That's the dx dt, which is conveniently labeled for us. 1 foot per second. And let's see, what else do we have? How fast is the top of the ladder sliding down? That's the dy dt. It's a question mark because I don't know it. When the bottom of the ladder is 6 feet from the wall. Bottom of the ladder, that's the x value, so x is equal to 6 feet. All right, so it looks like this is going to be another Pythagorean theorem, right? We've got a right triangle. We've got a right triangle. We've got a 10 here that's staying constant, but these two legs are going to be changing. So I'm going to relate it with the Pythagorean theorem, but before I do, notice that I have the hypotenuse, and I have one of the sides, but I don't have the other side at that particular moment. And as the other example demonstrated, we're going to need it. So we're going to need the y value. Looks like it's the exact same Pythagorean triple. How convenient is this? If this one is 10 and this one is 6, then it must be 8 feet up from the wall. So it's a 3, 4, 5 Pythagorean triple. That's all being doubled. Feet. Okay. As we said, we're going to relate this with the Pythagorean theorem, where we have our 10 being constant as the hypotenuse. 10 squared is equal to an x squared plus a y squared. Hey, what shape would that be if you graphed it? Would it be a circle? Okay. So I think that we're ready to take the derivative. Yeah. Derivative of 10 squared is a big fat 0. And on the right-hand side, we've got a 2x dx dt, and then a 2y dy dt. What are we looking for? We're looking for dy dt, so we're going to isolate this guy. So we're going to subtract over the 2x dx dt, divide it by 2y. In the process, the 2's are going to cancel, and it's negative. Didn't we expect that it was going to be negative? So on this particular problem, as the x increases, the y has to decrease. Okay. Is equal to a negative x dx dt over, why don't you center that? Okay, over 1. Plug stuff in. Let's go. So dy dx. What? Why did I have that as a dx? Why didn't anybody say anything? Because you're at home in your office recording this all by yourself. Anyway, so let's plug stuff in, shall we? So negative x, the x we said was 6. Our dx dt we've labeled as 1. Get out your calculator. Over your y value, which was 8, which reduces to negative 3/4. Let's throw some units on there. So coming back up over here, let's see, x is measured in feet. Dx dt was measured in feet per somethings, sec. And then y is measured in feet. And then some of these feet cancel like those, leaving me with feet per second. Okay, so recap here that on this particular falling ladder problem, as the ladder is being kicked out, or it's scooching away from the wall, that's the correct term for it, scooch. It scooches to the right 1 foot per minute or per second, and then at that particular instant, it is sliding down the wall at 3/4 foot per second.